You asked your AI assistant about something that happened last month, it gave you a confident, detailed answer, and it was completely wrong. Or maybe you are building an AI product and users keep flagging that the outputs are outdated or maybe made up. In other words, the AI is hallucinating. But what's actually causing it and how do you fix it? Hey, I'm Andrius, tech lead at Oxylabs. In this video, I will explain what data grounding actually is, then how it's different from the fine-tuning and RAG, and why fresh web data is that fuel that makes it work. By the end, you will know how to think about grounding and where it fits in an AI system you are building or evaluating. Let's set the stage. When an LLM is trained, it learns from a massive snapshot of text, web pages, books, code, articles, everything up to a certain date. After that, the model is frozen, the world keeps moving, but the model doesn't. So when you ask it about something that happened after its training cutoff, it doesn't say, I don't know, it fills the gap. The model generates the most likely next words based on its training. So you get a fluent answer even when it has nothing solid to base it on. That's a hallucination, not a bug. It's a structural consequence of how those models work. Think of a textbook printed in 2023 still being used to answer questions now in 2026. The facts were true when it was written, they just haven't kept up. Data grounding is the fix. At its core, it means connecting LLM outputs to trusted, up-to-date external data, and it does that at the query time, not at training time. The model itself doesn't change, what changes is the information it's reasoning over. Instead of relying what it memorized during the training, it pulls in real, current facts before generating an answer. Think of the difference between a doctor who memorized the textbook 10 years ago and one who checks your live test results before diagnosing you. Same training, completely different output. Here's what the grounding workflow actually looks like. First, query understanding. The user asks a question, then retrieval, where the system goes out and fetches relevant current data from trusted sources. That could be a database, a live API, or a web scraper, or even a knowledge graph. Next, that data gets injected into the prompt before the model sees it, and then the model generates its answer working from real up-to-date facts, not training memory. And optionally, one last step, the model cites where its answer came from, so the output is auditable. That's the full loop. That's how grounding works. But to really understand it, it helps to see what it's not. Two ideas get confused with grounding all the time, and both are worth clearing up. Let's begin with the one people often reach for, grounding versus RAG. Is the comparison that trips people up the most because at first glance they look like the same thing. RAG stands for Retrieval Augmented Generation, is the most common way to implement grounding. You index your documents into a vector database. When a query comes in, you run a semantic search and inject the matching chunks into the prompt. Now that sounds a lot like grounding, and it's easy to treat them as the same thing, but they are not. Grounding is the broader principle. It means tying an LLM's answer to a trusted, up-to-date external data so the model reasons over real facts instead of memorized ones. RAG is one way to get those real facts in. Grounding is bigger than that. It also covers live web data fetched at query time, real-time APIs, and structured knowledge graphs. RAG is one tool in that toolbox, grounding is the whole thing. Next confusion to clear up, grounding versus fine-tuning. Fine-tuning takes a base model and retrains it on a focused dataset. A legal firm might fine-tune a model on thousands of contracts, a healthcare company might train it on clinical notes. It reshapes how the model speaks, its vocabulary, its reasoning style, and its domain fluency. But it doesn't add new facts. Ask a fine-tuned legal model what a judge ruled last Thursday. It would still hallucinate. The facts it was trained on are frozen at whatever date the fine-tuning data ended. Grounding is the opposite approach. It doesn't touch the model at all. It only injects what's true right now into the context window at the moment the question is asked. So the mental model is this: fine-tune for style and format, ground for current facts. It's not that one is better than the other, they are often used together. But here's what people underestimate. Grounding only works if you feed it a steady stream of fresh, accurate data at real scale and real time. Internal documents, databases, and APIs can handle a lot of that, but some AI systems need to reason about public web. Think of pricing, job market trends, competitor activity, or news. For those, you need live web data at scale. And that's where web scraping infrastructure comes in. It becomes the data collection layer for grounded AI, the reliable source of fresh web data your system runs on. That's exactly what Oxylabs Web Scraper API is built for. Instead of building and maintaining scrapers yourself, you get a clean, structured web data on tap at the volume and freshness a grounded system needs. Feed your model that data through the API, and the payoff shows up fast. Fewer hallucinations because it's reasoning over real facts, real-time accuracy because the data stays current, auditability because every answer traces back to a source, higher user trust because responses are traceable, and no expensive retraining cycles. You update the data, not the model. Maybe you are building something that needs to stay accurate: a customer-facing chatbot, an internal research tool, an autonomous agent. In all of those, data grounding is the layer that keeps it honest. If you would like to try it, the link to Oxylabs Web Scraper API is in the description. It's the data layer we use to power grounding at scale. And if you want to go deeper, our full blog post on data grounding is linked below. Still have questions? Reach out to support@oxylabs.io or use the live chat on our homepage. Thanks for watching. If this helped, their video on RAG and AI agents is a great next step. See you there!